I'm told putting software into production has never been easier. You just throw Kubernetes at it, right? No, no. Even with wonderful tools like that, putting software live is still fairly painful. We've definitely got better at it. DevOps is probably as good today as it's ever been, but I wouldn't describe it as easy. You've still got to know how to use those tools, of course. You've got to plan your provisioning. You've got to plan for monitoring and telemetry and security updates and scaling and infrastructure as code, which I believe means you choose between swearing at Terraform files or swearing at YAML files. It's not really surprising that the process of putting code live is a whole sub-profession in itself. And it's also not surprising that there are services out there offering to do it for you, to take the pain off your plate. I personally would never start one of those businesses. It scares me too much. You can become an expert at the things you need to be expert at, the provisioning, monitoring, security stuff, but you still get so many other problems that are really daunting, like user demands. Every one of your users will want a slightly different set of features, and they will all want 100% of the things they want right now. You have a really unique scaling problem. You're going to be trying to scale up your user base while every one of your users are trying to scale the demands they're going to put on you. That's fairly terrifying. You have a huge usability, user interface problem. You've got to be more usable than AWS. Actually, that part seems possible, but the rest sounds really hard. But it's a rule of thumb in our industry. If there's a bunch of really hard problems out there, there's going to be someone who enjoys solving them. And when I find out about them, it's a rule of thumb that I'm going to want to get them in and find out what makes them tick. So I'm joined this week by Anurag Goel. He is the founder of Render, which is a hosting platform somewhere between a modern Heroku and a simplified AWS. They've been building Render in Go for several years, and it's getting huge. They're taking on something like 150,000 new users a month. How do you do that? How do you manage the scale? How do you manage the infrastructure? And how do you keep them all happy? What are the design decisions you have to make and live with? And while we're taking notes, how do you get 150,000 new users a month? You know, if you're starting a software as a service platform, you might want to know what the secret to that is too. All seems worth knowing. We're going to dig into all of it and the impact of AI on the hosting market. What happens when so many people are delegating their hosting decisions to an LLM? How does that change things? Before we begin, this episode has been sponsored by Render, so let me tell you what that means and what it doesn't mean. They have no control over the questions. They did not get a list of questions beforehand, and for the record, I think that would be a terrible idea. People are often at their most interesting when you get them thinking on their feet. I think knowing the questions beforehand would do everyone a disservice. Render did get a preview copy of the episode before it went live, and they got to choose the release date of the episode, which in practice means they jumped to the top of the queue. So with that made clear, it's time for me to play host to a hosting expert. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Anurag Goel. Joining me today is Anurag. How you doing, sir?
I'm doing great, Chris. It's really good to be here.
I'm glad you could join me. Where are you coming in from?
I am based in San Francisco.
So your apartment costs are sky high.
I like to not think about that.
Okay. We won't start on a downer. We'll start on something cheerier.
Yes.
So getting straight to the point, right? Render, it's one of these hosting platforms that people will be reminded of Heroku, right? And like in some form, it's like I can host enough stuff there that I don't have to worry about DevOps. And I was thinking about this, and I thought, well, if I were trying to build that 10 years ago, honestly, I wouldn't know how to build it. If I were trying to build it today, I'd probably say, yeah, we need to hire a bunch of Kubernetes people and a good enough web designer to make me a nice web platform. And that would probably get me to version 1 of a hosting-esque platform. Is that roughly right?
It depends on the people. So, you
True.
these days, if you have someone who understands Kubernetes incredibly well and understands developer experience and can use Claude Code or Cursor or VS Code effectively, then maybe just one person can try to build the very, very, very first version of an internal or even an external developer platform, but it'll be missing 99% of the features that they will eventually have to build.
Okay. Okay. In that case, I was expecting you to say it was a little bit harder than that. But if you're thinking it's easier, once I've got my MVP of this, which I'm going to say that static hosting hosts enough of a JavaScript site and enough of a Postgres database that I'm running.
Oh, yeah.
What makes it hard after that?
Yeah. Well, hosting a Postgres database actually makes it 10x harder. So the
Really?
MVP would actually just be simply maybe a static site host or a simple Python website hosting thing where you could run a Flask API. Because even static versus just pure backend web service, those are two very different things.
True.
Because for a static site, you have to have a CDN in place, you have to invalidate caches, you have to do headers properly. So there's a whole thing that goes into building good static site hosting. But then the way you start maybe is by just simply hosting a backend HTTP service. And that could be let's say it's a Python service.
Okay.
Um, the thing that makes it more and more complicated from that point on is reliability and scale and the 1,000 plus features that your customers will ask for once you start at this point. And the next feature they might obviously ask for is like you were saying, a Postgres database. And building a reliable, scalable, enterprise grade Postgres is a fairly large endeavor. And this is why there's only so many solid Postgres hosting companies in the world. Um,
Yeah. What makes it hard out of interest? I mean, I feel I'm naive, but that's why I've got an expert in to explain to me. It feels like it's just okay, here's another process that needs to have a decent chunk of disk reliably available.
well, my life would be significantly easier if that were the case. So I think the main thing that makes it interesting and hard is making sure that all the operations of things like um, backups and point in time recovery and high availability and disaster recovery. All of
Yeah.
those things are built into the solution and are completely hidden from the user because they pay you to not see those things. And you have to give users an interface that allows them to size their Postgres up and down. You have to figure out how to give them the right level of observability into your Postgres. That's a lot of work. You have to make sure that if your underlying hardware needs to run maintenance for whatever reason, because machines fail, then their workloads are interrupted as little as possible. You have to
Yeah.
make sure that you have the right performance on both the compute side and the disk side, because disks have varying levels of performance, right? You could
Mm.
host something on a local NVMe SSD, or you could host something on a network disk like an AWS Elastic Block Store. How do you make sure that when you start up a new Postgres, you have a system that reliably attaches whatever disk that you're creating, allocates a machine where you have to host the compute, and makes those things talk to each other performantly. And then if things are running hot on Postgres, as often, some config might require your Postgres to be restarted, or users might change something that force the Postgres to consume all its CPU. There's all kinds of those things that come up in production use. And then
Yeah.
when you expand this to essentially, in Render's case, millions of users doing all kinds of things with Postgres, then it becomes really interesting. And then when you expand it to people using uh, Postgres from other providers and migrating over to Render, that makes it even more interesting. How do you make the migration as low downtime as possible? How do you set up follower databases? How do you set up, read replicas? How do you set up multiple read replicas?
How do you punch through firewalls?
Yeah, of course. Yeah. I mean, the
Yeah.
other big thing is uh, private networking for your application and Postgres. So a lot of providers simply offer a public URL for your Postgres, especially if they're dedicated Postgres providers. Then they'll give you a public Postgres URL. Obviously, you have to build authentication. You have to give people a way to log into their Postgres using some sort of proxy and so on. But if you are an end-to-end full stack multi-service orchestration layer like Render is, then you would want to build out private networking between your website or your backend service and your Postgres. And that means that your backend service should be able to talk to Postgres without going over a public internet connection. And that implies building out a way to assign internal IPs and then having a service name for the internal IP. So doing service discovery, having internal DNS,
Yeah.
because instead of giving users internal IPs, you actually want them to have a name.
Yep.
So the IP could change if the Postgres restarts or something happens with the compute process. And so how do you make sure that the application has a stable identifier? How do you make sure that read replicas have their own special identifiers? So, I could go on and on.
You're smiling like you enjoy this problem, and yet you're filling me with terror, to be honest.
Well, this is why Render exists. This is
Okay.
exactly why we built Render and continue to build not just a really strong enterprise grade Postgres, but also the entire infrastructure that allows companies to not just start really quickly, but also to scale on this platform on Render as they grow. And in that sense, I think Render is perhaps the uh, really the most forward-thinking cloud that allows you to both start quickly, but focuses on how your needs will change as your applications become more complex, as you
Okay. Now,
start creating more and more services.
now that sounds good, but I'm gonna have to get you to outline why I should believe that with details. That's what this show's
Yeah,
about.
absolutely. I'd
So,
love to.
so from what I'm hearing from you, I see a bunch of problems. One is that for a service like this, everybody wants to not think about any of the features of the database except the ones they want, right? Like maybe I need point in time recovery, but I don't want to think about any other aspect of Postgres.
Yeah, but someone else might want extensions.
Yeah,
And how do
yeah,
you make sure the right extensions are available?
yeah, yeah. In
How do
fact,
you do version upgrades of Postgres? I mean, again, I could go on.
yeah, yeah. So how do you and then we have to multiply it kind of horizontally by it's great that you support Flask, but I want to use Node or I want to use Rust as my web server or whatever.
Absolutely.
You've got this universe of features and a universe of demands. How do you decide what's worth focusing on?
Oh, that is the eternal question, isn't it? I think it all comes down to some combination of um, the biggest problems that the broadest subsection of the developer community is feeling, and um, and then also thinking about how you can offer a unique solution there. So, as an example,
Hmm.
um, S3 despite its configuration complexity, is fundamentally a great product. Amazon has been building it since 2005. So it's a product that has matured over 20 years. But not only is it continuing to innovate, it also continues to scale, and the world runs on S3. If S3 were to go down across the board, we would all shut our computers down and watch TV. And maybe TV wouldn't work either.
Yeah, I think we've seen that happen a couple of times, right? In
Well,
internet
the good thing
history.
is that it doesn't happen. I mean, I don't even remember the last time S3 had an incident. There's a bunch of AWS incidents
Oh yeah,
that have,
that's fair. That's fair.
yeah,
Yeah.
but S3 itself, the service is tremendously stable. And so, a lot of render customers, they ask us to build object storage because they know that S3 is hard to configure and render would do a better job with the usability side of it, which, we will. Um, But should we build an S3 replacement, or should we solve a problem that AWS hasn't solved? Um,
You must be tempted to say, why don't we just put a nicer interface on S3 and call it ours?
I think that's right. But even then, you're taking on a lot of responsibility at the end of the day, even if you put an interface on top of S3, because the most obvious thing then you have to think about next is what happens when S3 releases a new feature or changes its API, or there are specific um, performance characteristics that your users need that are only available in the new version of S3's API. And so you have to keep up with S3 if you simply decide to put a skin on it. And your users would actually be, I think, better served, even if it takes a little bit longer to get started on S3 and to secure everything, and you deal with IAM and security groups, and it's a bit of a mess. Um, I think skinning AWS products is a failing proposition over the long term, because you have to really provide true value on top for it to make sense. And it's very hard to do that with a simple skin. Um,
Yeah, okay. Yeah, I'll give you that. Then let me pin this down on something technical, which is like, I notice you have a system for configuring deployments using YAML blueprints, you call it.
Mhm.
Right. And that came into my mind. Like YAML, it's great in that it's that kind of user friendly, or at least developer friendly skin over a more complex service. But you've got this problem that YAML isn't very good at expressing really complex ideas. So aren't you there hiding complexity in a way that's going to come back and bite you when someone says, I need that feature?
I guess the question is, what kind of ideas are you thinking about when you think about YAML? Because there is the definition of infrastructure, which is kind of sort of static, and then there's code, which is dynamic. And yes, YAML is not a full programming language.
Hmm.
And you can't express, loops and stuff in YAML, although there's people have tried. Um, but if you wanted to specify a state of the world that you wanted to exist without adding logic, without adding runtime complexity, then YAML actually is very good at that. And so is JSON. And right now I'm treating YAML and JSON interchangeably. So those are
That's fair.
data formats as opposed
Yeah.
to compute formats. And code, general programming languages are more code expressions, runtime expressions, whereas YAML, JSON, those are all data formats. And as long as you can think about your infrastructure specification as data, YAML and JSON are actually quite reasonable as specifications. And you don't need to be more complex. But I mean, another way to think about this is, look, people have built hugely complex systems with millions of lines of YAML writing Kubernetes code at the end of the day. All Kubernetes manifests are YAML,
Yeah.
and there's only so much you can do with static YAML on Kubernetes, which is why Kubernetes has a Go API, as it's written in Go, there's a Go SDK. And so for more complex things where you have to deal with the API or deal with Kubernetes in a way that is much more dynamic, that's where you use, let's say, Go to talk to Kubernetes API versus specifying, sending it YAML files, which is what most people do because they think about their infrastructure as static. And it changes over time, but it doesn't change as frequently. So YAML
Yeah,
is
yeah.
fine.
It's mostly kind of snapshots, right? But
Exactly. It's snapshots, data.
do you find that are you perhaps saying that we offer YAML until it becomes too complex and then there's a Go SDK for render as well? Or are you working very hard to keep the design within the YAML space that you don't have to do that?
No, I think our philosophy here is uh, to use the best tool for the job. And for this reason, we expose multiple interfaces. We obviously expose YAML as a way to specify your infrastructure. However, we also have a REST API, and you can build really dynamic infrastructure projects using Render's REST API, and a lot of people do. So if you're spinning up things on demand, let's say your user wants a database, instead of writing out a YAML file for Render and then running infrastructure as code syncing, you'd rather use Render's API to spin up a new database if your user wants one, right? And so
Hmm.
for things that happen that need to be essentially programmatic responses to customer needs, it's much better to have an API. And essentially, you could also do the same thing with code, where you write some YAML, generate YAML using code, and then use that to sync. But for programmers, the ergonomic solution is actually to use a REST API, right? Instead of
Yeah.
generating YAML. And so we have a REST API. We also have a CLI, which you can use for other things, because often you're in a command line environment and you need to be able to, let's say, deploy a service or fetch the logs. But it's harder to do that with a pure REST API because you could string a bunch of curl commands together and make it really complex. Or you could just use high level um, verbs in a CLI saying, render get service ID. And it would show you, or logs for the service ID, instead of spinning up a curl command on demand. So it all
Yeah.
depends on the context in which you're operating, which is why people need different um, interfaces for different contexts. The ultimate context is, of course, when humans are designing infrastructure and they don't want to deal with infrastructure as code. They want to deal with an API. This is why we have our dashboard, which does everything that you would want it to do.
Yeah, yeah. What this is making me think of is, I don't know if you know of it, but I'll explain. So there's a tool for deployment called Pulumi, which I've used a
Mm-hmm.
couple of times.
Yeah.
And their answer to this question is, let's try and make the same SDK available in all the languages if we can. So whatever thing you're currently using, it will feel familiar.
Yes.
Have you ever been tempted to go down that kind of route where you just spray every possible option out to your users?
I don't think that Pulumi is that different from YAML. I mean, at the end of the day, Pulumi is just giving you a better interface, but still to define the end state of infrastructure. Um, and by that, I mean, Pulumi gives, instead of you writing YAML, Pulumi lets you express your infrastructure in specific kinds of code, and so you can use the built-in niceties of your programming language.
Hmm.
If you want to have 5 servers, instead of specifying 5 different servers in YAML with 5 blocks that are all the same with one thing that's different, you can run a loop in your programming language and say these are the servers.
Yeah.
And so they're just like they're programming languages that are imperative. I think in some ways, Pulumi is trying to use the imperative structure of programming languages to ultimately end up with essentially data that defines your infrastructure. So for render, we think that there are ways to use programming languages to define infrastructure more dynamically. And an example of that is, say, let's think about functions as a service.
Right.
Typically, when you are writing like a Lambda or something else that is a function as a service, that is infrastructure, and it's very closely tied to your code. And it has a convention that is understood throughout, where it gets a request, you have to return a response. And that is sort of another way to define what needs to happen when a request comes in. But that is, that is not just infrastructure. It's also defining the behavior or the runtime behavior, which is going one step beyond Pulumi. Because Pulumi doesn't
Yeah.
define runtime behavior of your code.
Yep. Okay. Yeah. Yeah. Um, yeah. I think I see. I think I see what you're getting at. I just. I wonder if eventually. I mean, let me step back. A problem I've seen with all kind of static infrastructure deployment systems is this problem where you end up with 5 almost identical servers, and then you
Yeah.
try and define a templating system and a for loop system in
Mhm.
YAML just so you can try and stay sane with that. And as it grows larger, the problem gets bigger and bigger.
Yeah. Yeah.
And
So, which is why I think you need to give people programmatic interfaces to define infrastructure than pure YAML. And so YAML is one way to do it, and it works well when things are simpler. Um, but also, going back to, obviously, the leader in the space is Terraform, and people have massive, massive Terraform folders in their code base. And they're actually using Terraform's uh, specific language, HCL, which is built explicitly to define infrastructure. And it actually takes every cloud primitive and exposes it as a high level object or resource in
yeah,
Terraform's language. And at the same time, uh, you still, anytime you need infrastructure to be more dynamic and spin up and down in response to things, Terraform breaks down. And so YAML, any kind of static infrastructure definition, is very different from spinning up infrastructure or spinning it down or modifying it in real time. And that's why at Render, behind the scenes, we use Terraform to spin up certain parts of our infrastructure. But we also have lots and lots and lots of Go code that does things on top of that simply to interact with infrastructure. And this includes spinning up databases. There's a lot of work that we do to spin up databases and to manage them, and all that code is written in Go. And
okay,
yeah, but the machines that those databases run on, uh, behind the scenes, you can define a static pool of machines using Terraform. And then within Terraform, you define an auto-scaling policy. But even that policy is static. But then behind the scenes, something is listening for when to scale up and down. And that's essentially a controller of some sort. But Terraform lets you define the controller, but the controller behavior is actually specified in code somewhere.
right. So you yourself are using a mixture of static definitions and code to react to the difficult bits,
Yeah,
and
exactly.
presumably that's the advice you give me as a user.
I think it depends on your needs. For a lot of companies, infrastructure is not as dynamic, nearly as dynamic as it is for Render. Um,
I can believe that.
a lot of companies simply need, a web service, a background worker, a queue, a database, and some sort of static site, maybe object storage. And their infrastructure needs don't change day to day. They just set it up once using Infra's code. And if they do change, then they change maybe in the sense of, oh, I have this uh, VM that is maybe 2 CPUs, and now I'm seeing more usage, so I need to increase the VM size to 4 CPUs. And that's where having infra as code, so you can monitor um, exactly what changes you're making to your infra. You can get it code reviewed. You can go through an audit process. You have that change in your code base for posterity. That's really the value of infrastructure as code. Um, and for that situation, you really don't need dynamic interfaces. It would be overkill to have
Yeah, yeah.
it go through some sort of API. Or having to use an SDK or Go code to define this. You just simply use like a render blueprint or a Terraform file. And Render, by the way, also has a Terraform provider for people who
Oh,
really want
okay.
to use Terraform. Yeah.
I the last time I used Terraform, I convinced someone else on the team to take that part of the code base over. So that's my feeling about Terraform.
I don't blame you. I think fundamentally, infrastructure, especially for application developers, is a stumbling block. And I just want my application to run as I expect it to. I want it to be reliable. I want it to scale. I want to push out new changes and have them show up quickly. I want the ability to roll back changes if something goes wrong. I want to be able to see exactly what's going on in terms of my application performance. I want to see the logs when something breaks. I want to be able to collaborate on it with other people on my team. And so these are all the concerns that trip people up today, because you have to do a ton of work to make this happen on something like AWS, or any hyperscaler for that matter. There's a lot of configuration. And the sad part is that everyone's configuration at the end of the day looks very similar.
Do you
And
think?
I mean, I know it. I think,
Okay. Because I would have
yeah.
thought it's like 90% the same, but all the difference is in that last 10% that people argue over.
So the differences there might be in terms of, well, instead of like I was saying, instead of a 2 GB RAM service, I need 5 GB of RAM, or instead of 3 instances of this server, I want to run 5 instances. I think those are the kinds of differences. Or instead of like a Java service, I want a Python service. I mean, but it all comes down to like, what is the core architecture that you're trying to support? And to your earlier question about how does Render decide what to build, I think for us, it goes back to what are the architectures that we want to support, and how are people building applications today, and what are the challenges that they're running into when it comes to the cloud, and how can we think about it in terms of higher level needs that these architectures have, and how can we solve those needs at the architecture level as opposed to having everyone spin up a virtual machine.
Yeah. But, okay, so let me give you a specific counterexample to that, because I can believe that a lot of these things are slightly different, but we've mentioned briefly Postgres extensions, right?
Mhm.
I was looking at this. I was trying to use Render with a Postgres database that had PG Vector installed.
Mhm.
And along that path, I found out that you had recently added support for PG Vector. But do you have this problem that there is a queue of people saying, I want this little tweak to this standard engine. I want this extension installed in, I don't know, Kafka or something. And there's this wave of micro demands that people need to be solved to get
Yeah.
to move forwards.
Yeah, I think that's a really good point. And this is really the core of how we think about building Render for companies that are scaling. So when you're starting out, your needs look quite similar because you have the same sort of server, whatever. As you scale, often the need to customize things comes from your need to get better performance, or for increased redundancy that creates more reliability. And so, with Postgres, as an example, certainly we had people who are asking us for extensions that are sort of super custom. They're actually an open source extension that 5 people use in the world.
Yeah.
And I think our goal is, um, again, to serve the 90% market where like Render should be able to work for 90, even 95% of the use cases out there. But there are these 5% use cases where maybe you are building a Postgres company yourself, or you are building an infrastructure provider yourself. And that is where I think you might need very low level control, which certainly like render is not going to let you patch the kernel. Most people don't even want, like 99% of the people out there don't want to think about patching kernels, which is why render is as successful as it is. And you have to tread the line carefully. So with Postgres, again, one of the things that people have asked us for over the years is, well, I want to configure this one parameter in Postgres. And
Yeah.
until recently, we had that happen through our support team, unfortunately. Uh,
Right. Yeah.
and that's not great, right? Because I don't want Dot to support to change a parameter. And now Render is going to release a feature where you basically just have um, your Postgres configuration file, more or less, that you can tweak, and we'll maintain the parameter changes. We'll tell you if a parameter change requires a restart. And so we're giving people more power, more flexibility. And that's one way to think about how we've done this for everything else over the years. You had to do a lot of work to give people the right level of flexibility without giving them the kitchen sink, which
Yeah.
is
Yeah.
the AWS approach. And over time, you do that by continuing to both anticipate your customers' needs, but also just having customers who scale on you, who give you feedback about the kinds of things they need. And we found that as customers have grown on Render, our largest customers often have needs that when we um, produce them and when we deliver them are incredibly similar to the needs of other customers who are coming behind them and growing to that scale. And so we're really learning from our customers about the right interface to build, but we're
Mm.
not submitting to the siren call of offering managed Kubernetes. Because if you did that, people could configure everything. And that's not the right answer. It's you can do that anywhere. I mean, not anywhere, but there's a ton of managed Kubernetes providers in the world. But how do you build a system where you don't need to use Kubernetes? At the same time, you get the best parts of Kubernetes that you actually want.
Yeah.
In one way, that's one way to think about render.
It's a really difficult design problem finding that sweet spot between giving people enough power that they'll always be happy and not giving them everything that you can never get any kind of unity in what you're offering, right?
Yes. And it's also possible to do in a way that gives different people different levels of control. Like there are some people who need that complexity and are sophisticated enough or have the desire to work with that complexity. So an example is you could expose a specific flag or a configuration parameter um, in the dashboard, and in your API and in your blueprint, as we talked
Mm.
about. But maybe uh, that parameter is only used by people who are sophisticated enough in their usage and their scale to be using infra as code or to be using the API.
Mm.
And so that parameter doesn't need to be in the dashboard because for most people who are managing their render infrastructure manually through a dashboard, they never get to that level of scale where they need infra as code. And so you have to think about, okay, well, what is the right place for this parameter? Everything should be in the API at the end of the day because that's
Mm.
the most flexible way to use render. But not everything needs to be in your face in the dashboard.
Yeah, yeah, yeah. You must have. I mean, how large is your UX design team?
It's not that large. We're focused on hiring really world class talent, and then making sure that we can do as much as possible with as small of a team as possible. Because the larger you get, the harder it is to coordinate, and sometimes you just move slower. Even if you've added 10, often like 3-person teams can completely out execute 10% team trying to do the same thing because there's less communication overhead. And so
Yeah.
you can only solve so many problems with a 3-person team. So again, you have to think about how to structure your teams and your company. But I think it comes from having the right principles that you can apply to multiple situations. And so we have internal design principles and product principles as we think about how to do X, Y, or Z, that allow our thinking to scale even when we don't have a massive design team.
Give me an example. What's one of your principles?
Well, actually, it was similar to what I just described, where again, not everything needs to be in the dashboard. I think that that's an interesting way to think about. Okay, well, when does it make sense, and who are we building for? When do we add something to a dashboard versus not? Um, but another principle is um, minimizing surprise, uh, and by that I mean the dashboard or the system should do what most reasonable people expect it to do, and should not behave in surprising ways as much as possible. And when you get down to the micro interactions, I think it's really important to think about, okay, well, if you did this, this is not similar to how people interact with, let's say, I mean, the most basic thing is like, this is not similar to how people interact with modals, UI modals. And let's not try to change how modals work in render. Let's like make that similar to what people expect from UI interactions because other applications behave in a certain way. And so another example of this is, well, what are people used to when you think about filters? How should filters work, and how do developers, or not just, I mean, our users are application developers, but when we think about filtering in all kinds of apps, we've gotten used to a certain way of filtering things,
Yeah, that's
and
fair.
let's not try to build an entirely radical way of filtering that is so different that it confuses people.
Yeah, okay. You have just given me a bridge to a thorny technical problem I want to get to behind the scenes.
Of course.
Because when I go into web interface and I say stand up a new Postgres server, that especially in this kind of model, these are inherently asynchronous things, right?
Yes.
The UI is going to have to come back and say I'm standing that up, and eventually, 2-3 minutes later, the UI is going to have to update and say it's now ready. So I think it'd be very interesting to take the path from that first click all the way through the system and back. How do you handle that messaging?
Absolutely. So let's say you click a button saying create this Postgres. From the dashboard, it's an API call to Render's API, and the API itself will run a bunch of checks, make sure it's authenticated and all of that, and you have the right plan. And but then the API issues a request to another service, which is effectively a another API server that is built just for the infrastructure. So you have an API server for the render control plane, and then you have the infrastructure control plane, which has its own API server. And so that call then tells the infrastructure at a lower level what kind of Postgres to create. And it might require creation of 2 or 3 different resources, right? So as we were talking about earlier, you have a disk, you have a CPU process, you might have other processes like a read replica. And so that lower level infrastructure call then is serviced by this API server, which then is responsible for spinning up VMs or spinning up containers, and calling the underlying resources, allocating resources, and so the call from the original dashboard, that call returns immediately, but then a polling process starts effectively, or a
Okay.
WebSocket process starts, and depending on, I mean, render, we use both WebSockets and polling, depending on what it is. And we have a Go API, and we use channels, and channels are a good way to deal with asynchronous
I was
messages.
wondering if channels or a queuing system was going to come into this.
Yeah, and we also have behind the scenes we have our own queuing systems and workflow systems, and then there is at the end of the day, there is a thing that is listening to changes in the underlying the low level infrastructure. So when a disk gets created, it sends a bunch of messages to whoever's listening on, hey, a disk got created, and and then if that's the disk for this database, then I can signal to my API REST API channel, look, this database just got created, or this disk with this database is created. And then with Postgres, actually, in addition to spinning up the infrastructure, you have to wait for the Postgres process to run and
To warm up
start
and
up and
initialize
be
the
ready.
database, and yeah.
Exactly, to be ready to accept connections, and then you have to create the network connections that we were talking about earlier. You have to
Yeah.
assign it an IP, internal IP. You might have to assign it an external IP. You give it, there's a bunch of network configuration happening at the same time. But ultimately, what you're doing is you're listening to these events in the system, in our core infrastructure processing code, and you're responding to each event as it happens. And one of these events will be, okay, well, now the Postgres um, process is online and is ready to accept connections. And at that point, if you're polling, you'll get a request 2 seconds later saying, hey, is this ready? And then you send that back to the user. Or if it's a WebSocket, then you just respond to the user's WebSocket saying
Yeah.
this is ready. But I quite everything I described, even though it was long, it's still an oversimplification.
Yeah, I can believe that. But we'll try and get an architecture diagram without actually using diagrams for a
That's
podcast.
right.
But I'm surprised you. I mean, this seems like a classic persistent workflow problem with an event system.
Yes.
And I would have thought you can do that with channels, but you'd end up reinventing a wheel that's already out there.
I think we use channels also.
Hmm.
So just to be clear, I think the problem with channels is they're an in-memory solution. And if the Go process dies for whatever reason, then you've lost all that state, right?
Yeah.
And so you want some sort of persistent state. And this is why you build sort of a persistent queuing mechanism where
Okay.
even
You
if the
have to.
thing died, right? And so you don't want your Postgres to never be created because the Go process died midway.
Yeah.
And so even if things fail, which isn't um, often, or even infrequently, it's very rare, but for that rare situation you still want it to work.
Yeah.
And that's why I think you need to build this level of reliability, which at the end of the day requires some sort of persistent mechanism that stores data on disk somewhere at the end
So
of the day.
did you go custom for that?
I think it's a combination of custom, um, and then we're also behind the scenes using, for example, uh, when we talk about sort of this infrastructure control plane layer, um, part of that infrastructure control plane is the Kubernetes API server. And Kubernetes has controller managers and it has its own loops going on behind the scenes, but it also, like etcd, which is sort of the Kubernetes state store, uh,
Oh,
that
okay.
it stores data on disk. And so at the end of the day, you're using Kubernetes mechanisms to store persistent state and to think about like how the world is changing as events happen through the system. But then we've built our own things on top where we have a persistent queue. We use Redis
Okay.
and persistent Redis, yeah, and we make sure that uh, we have our own Go queuing background workers listening on it. And we're also soon going to start using our own workflow orchestration product for something like this. That product is in alpha right now, but I'm really excited to transition more of our own usage of workflows and queuing, our own needs for defining workflows and asynchronous tasks, um, being serviced by our own product that we're also going to offer to our customers.
Ah, I see. I was wondering if you were saying this is just a purely internal thing, or so you're dog fooding it at the moment.
Yeah, we're starting to. I mean, it's still in very early alpha, and so you have to be careful about where you dog food it. You can't just put it in production for the millions of users you have, right?
Yeah, yeah,
It's sort of how your status page should not run on your own infrastructure if you're an
yeah,
infrastructure provider.
yeah.
Um, yeah, uh, but yes, our goal is to mature this product by using it internally as much as possible. And we have so many uses for it internally. So I'm really excited.
Okay, I'm going to have to ask you because I don't think we've had that many Go users on this podcast yet, but we have had we've had Erlang people. And I know that they would answer the questions I've just been asking you in a very different way. How? So I guess the question is, how happy are you with Go? How well suited do you think it is to what you're doing? Is there anything you're jealous of from other languages?
So we're actually very happy with Go. Um, and the primary reason um, for my answer is Go is today the best language to work with infrastructure because a lot of infrastructure code is already written in Go. And so it's kind of a network effect. Um,
Yeah, yeah, okay. Yeah, I can see that.
And part of that comes from Google because Google is responsible for a lot of infrastructure code, including the core of Kubernetes, but also a lot of other projects. And Google is responsible for Go as well. And so that created the sort of network effect where more new infrastructure projects were also written in Go, and it makes it much more ergonomic to manage infrastructure because you can just use Go SDKs. And a lot of these things don't have SDKs in any other language, even, or like if they are, then they're not first class SDKs.
Right, yeah.
But to answer your question, the thing that I miss, uh, if I were to pick a language for a general purpose programming language, I'd always pick Python
Okay.
because it's just faster to get things done with Python, in my opinion, because it operates at a higher level. Now, Python is not as performant as Go, so there's that. And again, you have to use the right tool for the job. And if renders infrastructure were all written in Python, it would be much slower and it would cost us a lot more because we'd be spending, 10x as much on CPU and memory.
Yeah, yeah, I can believe it actually would for the kinds of workloads you're doing. Probably do
Yeah,
want a
because
lower
I
level
mean, the
compiled
most
language. Yeah.
obvious example is we have this load balancer or router that takes every single request that comes into render and figures out how to route it, which service of the millions of services that run on render to route it to. And you can imagine performance being incredibly critical for something like that. And by performance, I mean how quickly it can do it, but also how much CPU it needs, how much memory it needs. And so
Yeah.
we, right?
How
And so
large your
we've
thread pool
written
is going to get before you have to spin up another machine for your load balancer. Yeah.
exactly. And we serve well over 100 billion requests every month, which means, and these are just web requests. These are not even the internal requests that our services make, that user services make to other user services or their own services.
Right.
And so is this just the HTTP requests coming into render? And that's more than 100 billion. And these are served by our Go code. And I'll tell you, I'm really happy with Go because I haven't felt the need to rewrite it in Rust or something.
Okay. Just to be clear, are you saying 100 billion is the combination of people using Render and the people hosting on Render and their users are using it?
It's their users, yeah. So these
Yeah, yeah.
are HTTP requests going to all the services that all the people, the 3 million plus Render users have hosted on Render. So it's not API requests to Render.
Right. Yeah. That number is kind of terrifying. That would keep me up at night.
I mean, it does keep us up at night sometimes, certainly, when there's like a page, an alert going off because something's happening. Um, but we've gotten to this number over time. This is not something that, happened overnight. And we've been around a while now. And the way we've done this is very intentionally and carefully. And you run load tests, you run benchmarks, and you start to find patterns to optimize over time. And you start to build, kinds of caches and other things. And so, this is all state that this layer needs to keep. And we built it so that even if our core Postgres or whatever the state is for customer workloads goes down, this layer keeps operating. And that itself requires a lot of engineering on top. And obviously, there's the scaling and auto scaling part of it because our users can get a massive spike in requests and so on. But
Yeah,
when you
yeah.
reach a certain scale, each individual customer spikes don't really matter as much. Um, you know, I
Yeah, yeah.
remember back in the day, Render hosted the infrastructure for a U.S. Uh, presidential primary campaign.
Okay.
And this is not the presidential campaign; it's that party's presidential primary. And one of the candidates was using Render, and every time there are these primary debates, and so every time this candidate spoke about um, their platform, and at the end of the debate, there's a closing statement, and every time they delivered their closing statement, requests to their website shot up. And in
Right, yeah.
2019, that was actually a big part of our overall traffic. And so one user could still be very, very influential to how we were doing. But obviously, these days, that's not a problem.
Yeah. Yeah. I have to say, weirdly, the American presidential primaries make the news over here. And I think it's the only thing in politics where we hear about the pre-political races in other countries. They are
That's really
sufficiently
interesting.
famous. Yeah, they're famous enough that they actually impact our culture too. Which I don't
Yeah,
know what to
well,
make of that, but I can certainly make that there's going to be a lot of traffic spiking out of that.
oh, yeah. Yeah,
Yeah.
certainly.
So
And it taught us a lot.
it must have taught you a lot about observability, I'm guessing.
Observability, certainly.
Like,
Yeah. How do you build the right level of observability at every layer in the stack? That's really
yeah.
important.
How do you do it? I mean, again, I'm wondering if you've got like queues or actors streaming telemetry out internally.
Yeah, so we do have different levels of observability. Um, I mean, the most basic level is at the hardware, the virtual machine level, like the CPU memory on a machine. Behind the scenes, we do we use Victoria metrics as our core layer that receives all these events, observability events or checks or metric observations across all our infrastructure, our core infrastructure.
Mm.
And we moved to Victoria metrics from Prometheus because we found VM to be much more performant
Okay.
for our scale.
I've not heard of
And
Victoria metrics.
it's a great product, and it has actually scaled quite well with us, which
No.
I can't say for most products. So if you're looking, I mean, I don't know anyone over there, and I'm not I'm not connected to them in any way. I just know that we've been able to do a good job scaling with their product.
Okay.
And I know that when we first started doing it, we were using Prometheus, but now we use Victoria Metrics behind the scenes, and it's a cluster. It's distributed, and you also have to build out a system to take in logs from every single machine, but every single uh, customer process, because you need to show customers logs, right?
Yeah.
And you need to build a really performance scalable system to ingest logs and send them to the right places. And behind the scenes, we're using Loki, which is a log aggregation system, which is again built for scale.
Okay. Not heard of that
And
one.
we're using Vector for transformation and sending it to the right places. Loki is the thing that stores the logs, and it's built by the same people who built Grafana. And
Okay. Yeah.
yeah, and so we use Grafana. In some places, we use Datadog, although Datadog is madly expensive, so we've reduced our Datadog use.
I've heard that criticism.
And we've brought most of it in house at this point. Um, and we built our own systems across the board for observability. The interesting thing for us is a lot of the observability metrics, whether it's logs or traces or just plain metrics, we have to show a lot of them to our customers for their services.
Yeah.
And so we have to capture it across, again, like the millions of applications running on Render, and make sure that we can do this reliably, scalably. But then we also have our own diagnostic systems that has nothing to do with customer processes.
I was wondering if it was a single unified system that treats you the same, or if you have a separate. And what's the separation of those two layers?
The most obvious one is for our users, we built the UI for them to see everything, as opposed to just giving them a Grafana dashboard,
Right. Yeah.
right? And uh, the core of the uh, metrics aggregation layer and the core of the logging infrastructure, that's the same. And it doesn't make sense to have two different systems. But we, for example, have to monitor more than our users need. So we have logs or CPU or memory metrics or other kinds of things that are much lower level, like at the VM level, at the hardware level, and the network monitoring is very different. So we
Oh, yeah,
use
yeah. I can see that.
Netmon for a bunch of things, but our users really, for them, they care most about internal or external bandwidth. So for them, it's really important to show them the bandwidth that is being used by the services, but they don't care about the internal network monitoring that we have.
Do you have? Is it integrated into this system, or do you have another system for billing? I'm thinking like you must have something that captures how many gigabytes I transfer a week. And
Yeah.
is that the same system?
So the system that shows users their usage is the same system that is used for billing as well. Yes,
Okay.
because we're collecting usage data in the same place. But then we have the system that actually figures out how much to charge them based on that usage data,
Right.
and do other things. But the collection mechanism is the same.
Okay. Yeah, that makes sense. I was wondering if you were getting you'd have a synchronization problem without that, right?
Yeah, exactly. We have
Yeah.
to have a single source of truth, because you have to users, again, the element of least surprise.
Yeah.
You should always have the same data across multiple places in the system.
Yeah. Yeah, that makes total sense. So I'm going to move back into user space because there is one particular metric I saw you post on LinkedIn, which I would like to know how you do this because I want to steal whatever your strategy is. I'll be brazen about that. I saw you post on LinkedIn maybe a couple of months back that you were acquiring like 150,000 new developers a month. Correct me if I'm wrong.
Well, it has been corrected upwards, but I can't share. It's a much higher number now, but that
Okay,
was the last public number.
okay, that was something of a humble brag, but I love it. So I don't know how you get 150,000 or more users onto a platform. And as I do things in the developer relations space, I would like to know how are you getting that kind of growth? What do you think it boils down to?
So there's a lot of different factors that have contributed to this growth over the last several years. Um, you know, we were signing up 75,000 developers a month in maybe November of last year, and the 150,000 number comes from, I think it was March or April of this year. So we doubled that number really quickly. And this is just the new users every month. And I can tell you why that happened.
Yeah,
Um,
that sounds like a
okay.
good one to know.
Okay. So um, fundamentally, we're living in this really exciting time where it has become much, much, much easier to create and launch new applications. And there are smaller teams or individuals who are able to, and still talking about software developers here. I'm not talking about the people who don't know how to code, but the people who do know how to code are able to do a lot more, and they're able to test their ideas much more quickly. And that um, the bar to starting something and getting it out there, from a code standpoint, is much, much, much lower now because of AI. Because if there's one thing that LLMs are really good at, it is writing code and
Mhm.
helping you generate new code and therefore generating new applications. And render is arguably, obviously I'm biased, but I think render is one of the best places on the planet to host a new application. We make it incredibly easy for you to get started and then to scale from there. And so when people look around, they have these new applications. They're like, all right, well, I need to put it in the cloud. It's just the number of new applications being created is much higher than it was before. And that has led to more people using render and other things like it. So it's not, I'd say that doubling or more than doubling is not uh, just applicable to render, it's applicable to others as well. Obviously, they might have smaller bases. So they might go from, like, I don't know, whatever it is. But I think for us, that growth continues, which is why, again, our number is much higher now than it was. Uh, and
Okay.
and
Yeah.
so there's just many more new applications in the world, and render just happens to be a really great place to deploy new workloads.
Okay. Yeah, I can definitely see that AI is creating more services because I've created a bunch of side projects in the past month that I wouldn't have had time to get round to before AI.
Exactly.
And I have actually seen it try to deploy things to AWS, and it has not gone well, even with the
Yeah.
AWS CLI installed. Are you though? You must be trying to like somehow seed Chat GPT or Claude or whatever with knowledge about your company, and you must be leaning into how can we you must have done a lot of work for making it easier for human beings to use render, but are you now actively doing work to make it easier for LLMs to use render? Is that a
Absolutely.
marketing strategy?
Well, it's actually more of a product strategy um, as we think about the next 12 months. How do you make render easier for not just people who are building with LLMs, but for agentic workloads themselves? So agents need to spin up new kinds of compute as they perform a series of tasks. How does render become the place, the default platform for agents and humans to work together to
Yeah.
build these systems? But to go back to marketing for a second, um, no, we haven't actually done anything to influence our ChatGPT rankings. I wish we had a clear answer. So we don't really have a marketing team. We just have one marketing leader who joined 6 weeks ago. And she's
Okay.
building out a team, and she will build out a team, and we will obviously work on making render more visible to LLMs and obviously to Google. Again, we haven't done any SEO work either. Uh, but the good thing is that when you have developers who really love your product, then they do that work for you by, and not, it's not work, but like developers like telling each other about great products. I think that is just sort of the fundamental truth. And it's almost somewhat consumery in that sense,
Hmm.
versus, B2B products, B2B SaaS things, like people using B2B SaaS are not necessarily going around telling people, oh, you should use this B2B SaaS. I'm really excited about it. For developers, like, oh my God, I found this really easy and you should use render. And so we see a lot of that happening on social media and on blogs and in Slack channels. And LLMs are ingesting all this data. And LLMs are nothing if a reflection of what people are saying about something
Ah, okay, yeah.
on the internet. And so, because there's so many render users already talking about render on the internet, LLMs are also recommending render as the place to deploy your app.
Okay, yeah. Yeah, so I don't know how you replicate that, but I can see why you'd be benefiting from it. Totally. Do you do you wonder feeding into that? I mean, I can see a future where companies like Anthropic get more savvy to this and say, "Hey, Render, we will charge you $100,000 a month to make you the platform that our AI tends to recommend for deployment."
I think that's a really tough question to answer for companies like Anthropic or anyone building this foundation model, because one of the reasons people use foundation models today um, is they think that they're getting better answers than Google. These things haven't been gamed. They don't have sponsorships or sponsored posts.
Yet.
You and I would yet, right? But you and I would trust an LLM a lot less if we knew that it was striking these deals. Um, and that's a challenge for LLM providers. Um,
Yeah.
how can you maintain customer trust? With Google, at least, you know, and obviously it's different now, but back in the day, Google always had this sponsored post thing, which was very clear. And so there is a world in which I think LLMs build something like what Google did back in the day, where there's a sidebar with ads, and obviously those ads made it to the top
Yeah.
eventually, and now they're virtually indistinguishable from search results.
Yeah, I can totally see that future. I'm not sure. I think we'll have to see how it plays out. I doubt we can rely on the goodness of their hearts, but we might be able to rely on economic forces making it bad business to behave that way.
Yeah, I don't think we rely on the goodness of anyone's hearts when it comes to business.
Sadly. And you're right in the heart of it in Silicon Valley, so I'm sure you would know.
Oh, the stories I could tell.
Okay, I have one last question, and again, it's about unless you want to tell stories. Perhaps there are stories you want to tell, or perhaps you
No,
fear.
no, I'm gonna keep this simple.
Okay, we'll save that one for one day. We'll meet at a bar sometime, and you can tell me all the horror stories.
That sounds great.
Okay, so there's another thing I've been thinking about, and it relates to LLMs and the way we're changing how we program. Do you think we're going to be moving to a space where a provider like you also needs to support LLMs for debugging?
Yes, absolutely. Uh, I think if there's one thing, again, LLMs are good at, it's ingesting large amounts of data and trying to find patterns in it and surfacing those patterns. Um, and debugging at the end of the day is exactly that. Humans looking at lots of different data from different places. It's logs, traces, profiling data, looking at and even coordinating it with the source code, and looking at abnormal behavior, abnormal requests. All of that data can and should be fed into an LLM with the right kind of context and serve as the right kind of context with the right kind of prompts to help developers find that needle in a haystack. What went wrong? And whether render builds it um, into our system from scratch, or whether we partner with someone, or if maybe there are companies. I mean, Datadog has an AI SRE now, and Datadog could could effectively ingest all this data, and does ingest a lot of data from render already today. And so if you're
Mm.
using Datadog for a bunch of other things, you could use the AI SRE within Datadog for it. But I do think AI debugging is going to become almost the default once these tools get better.
Yeah, I can see it being first line support very easily. And I can see there being
Exactly.
demand for your telemetry systems to feed into, I don't know, a RAG system, or for you to pre-chew prompts about failures.
Yes. Yeah, absolutely. I think render's actually uniquely placed uh, as an infra provider to have all the data that you need for debugging. Because guess what? When something goes wrong, we're the first ones to know.
Yeah.
And we, because render works directly from when you push something to GitHub, and then we take that all the way to production, render has access to the entire life cycle of your application. And we have your commit data because we deploy on every commit. And with obviously with the right kind of user permissions, and making sure that this is something that users want us to do, you could build a system that looks at all of this data for users, and helps them with this first line of defense, like you said,
Yeah.
to give them a sense of what's going on.
Is that something you're actively working on?
I can't speak uh, to sort of future products. I mean,
Oh, I thought
sometimes
I'd
I
lulled you
do.
into a false sense of security there and I can get away
Ah,
with it.
uh, I think it's something that I'll say, we're obviously, clearly, we're actively thinking about.
Mm. You might, I mean, yeah, I just don't know how. Okay, maybe that's a question for someone else one day. But obviously, there's a vast amount of data from the GitHub commits to the load balancer to the database logs, and you've got it all there waiting.
Exactly.
And I don't know how you boil that down, but I can see how useful it would be for when my app crashes.
Yeah, it's also really useful within render because you have these interactions between different services. Like you said, there's a database, there's your, let's say, website backend, but maybe there's a third internal service that website is talking to, and then you're making these external API calls. And so render has essentially all of that, and not just render. I mean, AWS does too for AWS users, and all the cloud providers will have this sort of data.
Yeah.
And the question is, um, do you rely on something like a Datadog uh, to specialize on building this tool, or do you build one internally? And I
Hmm.
think that the answer is probably both, because for Datadog, uh, you probably have, and increasingly people are becoming multi-cloud. So people have systems from multiple cloud providers. And I think one of the reasons Datadog or any observability company can be successful is because they have integrations with all these cloud providers, multiple ones, and
Yeah.
systems, and they can give you this unified view. Um, at the same time, I think Render has better information than Datadog will ever have about your systems running on Render.
Yeah.
So I think it's Render's responsibility to also do this work at some level. But then I think Datadog could do this across, let's say, a different level. And so that's why the answer would be both.
Yeah. Yeah. Okay. Yeah, I can see that for different reasons. I think you'd both be crazy not to be working on that at the moment. Yeah. Okay, so speculatively in the future, what do you think the future will look like? Am I going to find that one day I get I get a message from my system saying the web server has crashed, and here's our diagnosis of why, and here's what you should do. Would you like to click yes?
So Render already does about 90% of that, except for the would you like to click yes part for now.
Okay.
Uh, We don't really like send you an email, a Slack notification when things are down, and we give you sort of the exit process code and the log message. We can link to the log, and you can see what's going on. But yes, I think uh, we'll also start. There's already systems that self-heal. They're already, when things go down, you spin up a new version of the app, and Render already does this, where like it actually has the ability to restart your app automatically if it's unresponsive. I think what we'll see is an increasing intelligence being built into these systems, and with that increased intelligence, maybe more complex failures than simply your app being unresponsive. More complex failures would lead to more automated actions. And a really simple example of that, a procedural example of that is, oh, I'm looking at my queue length. And if I'm running these background workers that are working off of a queue, if my queue length is beyond a certain point, if I want to make sure that my queue never exceeds like 10 items, but if it's at 11, I spin up a new worker automatically, and I start reducing my queue length. I think that's the most basic example today, but I think we'll see an explosion in the kinds of things that can then be automated, whether it's scaling, whether it's alerting. AI will and can help us help infrastructure be more autonomous. And I think we're moving
Yeah.
towards a world where infrastructure is and can do a lot more autonomously. It won't do everything, but it'll do much more than it does today. And that's also the future that we want to build with Render, autonomous infrastructure. I think that is really, truly the future that we want to live in.
And do you think you'll sleep better at night with that in place or worse? As the person responsible for it.
I sleep well at night no matter what. And I think
Okay.
to me, it's actually really exciting that we're in this world where these tools are available to us that can do more and that are smarter. And obviously, you have to build it in a way that doesn't have things like false positives and that don't take the wrong actions. So there has to be a very stringent level of control over what you allow AI to do autonomously. And there has to be a human in the loop often. But for the human in the loop, to start with, they'll get a lot more information up front that they would have to spend like an hour or two trying to obtain today.
Yeah, yeah. I would have thought just being able to pull together the Git logs with the deployment and crash logs. I mean, these things thrive on good context. I would think you're in
Exactly.
a very good place to pull that all together. I look forward to seeing what you do with it over the next year, which is going to be a very busy year, I'm sure.
It will be, and I'm excited about it.
Cool. Well, I'll leave you to go and build it. Anurag, thank you very much for joining me.
Thank you, Chris. This was great.
Thank you, Anurag. I'll tell you one quick fun story before we go. So I was trying out Rend. I was kicking the tires on it, unsurprisingly, and just hosting something small website. I committed a change to the code and I pushed it, and I'd set up their MCP server. So I said to Claude, which I've been using a lot lately, has my change gone live yet? And it whirs away and queries their endpoint and says, no, it's not gone live. And I've looked at the logs, and it looks like your most recent commit introduced a linting error, which caused the GitHub action to fail. Here's the diff that would fix it. Would you like me to commit that change and push? And I said, yeah, that sounds great. And it whirs away again. And after a few minutes, says, yep, that change has now been pushed and it's live on the website. And here's the URL. What a future to live in. And then 2 minutes after that, I get an email from GitHub saying that the first deployment had failed. Way too late to do anything about. The way we provision things and the way we deal with diagnosing errors and the whole world of frontline support, it's all going to change. Email notifications are going to look completely vintage. These are crazy times to be in. We best go and figure out what the crazy times look like. So, before you go, if you've enjoyed this episode, please take a moment to like it, rate it, share it with a friend, share it on social media, and make sure you're subscribed because we'll be back soon, of course, with another interesting voice from the software world. But until then, I've been your host, Chris Jenkins. This has been Developer Voices with Anurag Goel. Thanks for listening.